Okay, well, thanks, Pete, for bringing the subject to the front of the table. Our panel covers the area of analytics and AI, which I think, as everyone in the room can imagine, is a huge spectrum of space. So we'll definitely look for some audience input to kind of guide the interest in the room once we introduce our panelists. And so I'll kick it off, and all of our panelists have LinkedIn pages, so very easily to access a broader bio. So with that, I'll just impose a little rule that we just have 2 sentences to get on with the panel. Where we are today in terms of our role, and secondly, what our focus is in AI. Good afternoon. My name is Don Morrison. I work currently in the venture space with venture seed funds, funding the venture companies at the first stage. Appropriately so, my focus and the team's focus is largely artificial intelligence and large cloud-based data problems that we invest in. We're typically the first money in, and it's largely a software play. So with that, I'll just go across the room and ask each person to introduce themselves and give us their 2 sentences.
Okay, I'm Dan Tamir. I'm an associate professor of computer science in Texas State University. And the way I connect to this is through research and teaching.
My name is Amir Sternhell. I'm the Chief Strategy Officer of Certainty. Our focus is at the data layer. We enable data to be self-protected, as well as enabling data to be self-aware, which has a lot of applications in terms of AI, behavioral analytics, and so forth.
I'm the guy who just spoke.
Hi, I'm David Inbar, founder CEO of Digitalytics. Our focus is applying AI and machine learning to wholesale energy markets, and in particular, the way prices behave and predicting prices in those markets, and eventually also predicting users' carbon footprints, but we'll come to that later.
Hi everyone, I'm Sacha Fontaine. I am a utility analytics consultant at SAS. SAS, for me, is not software as a service, but statistical analysis systems. We've been around since 1976, so we're the OG of that term. What we do is we're a software company that provides an analytic platform for businesses to run their own analytics, and that includes utilities, because now that AMI is prevalent, they're able to do a lot of analytics by themselves.
Great, thank you. We'll have 3 opportunities for the audience. The first will be just kind of a show of hands or a voice in terms of your interest, and we'll quickly do that in a moment. And then the second is a Q&A session at the end to interact with the panelists, and then the third is during the network period for more in-depth. So what's great about the panel is we really cover the spectrum of analytics and AI fairly well. And I'll just put out some of the themes, and maybe as I go through each of the 6 themes, you can give us a show of hands of your area of interest. So a fair amount of data expertise, from the data sources all the way to managing large cloud-based data sets. Any particular interest in that area across the audience? Next up is the whole area of analytics, the computational side, prediction side, description side of data, all the way through to analytics. A number of our members are quite strong in that area. Okay, great. Followed by data and analytic application security, and along with that, the privacy matters of analytics and large data sets. Okay, 3, 4, 5, show of hands. And then the applications of analytics and artificial intelligence, everything from what's relevant at this conference, from smart grid through to the data sets of consumption and supply, distribution networks. Interest in that area? Okay, 3, 4. And then energy as a field, as the industry, any commentary around the energy? Okay, good show of hands. And then the public sector, state and local government. We'll put the CIA and Defense Department aside. Okay. With that, it appears it's analytics through to the applications in the energy space. And so maybe with that, Pete, I'll ask you to kind of connect the keynote in a couple minutes with what you feel vector around those 3 or 4 themes as a starting point.
Does that mean that the keynote didn't connect those things to? No, I'm just kidding. I'm kidding, Doug. Maybe it didn't. But thanks for the appreciation there. So what we see is our heritage has really been about accessing the data on behalf of utilities. And over the last, I'd say 5 years, we saw an increasing number of issues surfacing across our user community, particularly as it translated into CapEx spending on the distribution grid. And it was through the feedback that we received from our user community that we really started, from an application perspective, focusing in on what blinks and what certain power quality measurements that we capture for utilities today actually meant. And as it turned out, with the introduction of the F-150 Lightning and other electric vehicles, we had an increasing number of utilities coming to us to think through how we could leverage the data that we capture, about 100 billion data points a year, and how the electrification of transportation was going to impact power quality and how that was going to impact the integrity of assets like pole top transformers, and then in the aggregate, the distribution transformers behind those. And so right, there is a nexus here, and in our opinion, any utility that's already invested in AMI or other forms of communication to access data, or any utility that's thinking about getting to the next stage of connectivity and analysis with data, it is critical that they start to pinpoint where the most vulnerable pieces of their distribution grid or the assets that they monitor are for that utility. And then from there, how to really deduce the amount of data, which is voluminous, down to a synthesized way that's really relevant. And so from the application perspective, where we see the most demand from our 265 utilities we support today is really on fortifying pole top transformers and distribution transformers and using AI to do just that.
Amir, why don't we focus on the first 2 that we heard about of interest, analytics and AI, and you can kind of select and where you're seeing the trends and the innovation.
Well, my role on a day-to-day basis is to get all of you here to be reoriented. There is a paradigm change. Begin to focus on a data-centric orientation. So the essence of it is you have technologies today that can, from the origination or that input is, whether it's a sensor or whether it's the data itself, it could bind itself with some policies and rules and begin to enable it to be consumed for AI and analytics. The beauty of it is that most corporations today, not so much the utilities, because they haven't even gone there, but they fail in terms of really figuring out how to take whatever they have, put it in a cloud, and begin to factor some abilities to process it for AI. It doesn't actually happen. Most corporations fail, and they're locked into some sort of a data gravity. And in this instance, they're losing out on a lot of opportunities to really figure out AI. So these are the things we're trying to basically solve, and our technology enables the ability to have data itself that is fully governed and fully protected in its flight and its process. So these are things that I'm trying to reorient the market, that we can do this also for utilities. We can also figure things out from a sensor perspective.
Thank you. Same, sir.
Okay, so I was a bit surprised to be invited here because I'm known as a contrarian, so I'll be contrarian as I am. And I would say that I'm a bit more concerned about artificial stupidity than about artificial intelligence. And why am I saying this? because my problem is that research and development in AI and data analytics sometimes just go straight into a black box. There is a black box for machine learning. We try to train it with data. And sometimes we succeed, sometimes we don't. And how do we get the data and what type of data? So I'm more concerned about doing the real research and the real development, going into the black box. For example, understanding how human perception affect decisions of humans, etc., and embedding this in my research and development. Actually, I didn't say I also have I'm an entrepreneur. I have a couple companies, and one of them is dealing with big data exchange, somewhat similar to Bitcoin, but instead of dealing with digital coins, we deal with big data. And the other one is dealing with compressing of sensor data networks, and there we are trying to do some interesting things. So maybe later on we can go more into this if there would be questions.
Thank you. David?
Sure.
Your views?
Yeah, so our models produce signals that directly drive $100 million pieces of generation equipment or major investment decisions. And so before we embarked on actually building models, we realized we had to create a platform. That platform does two key things. Number one, it marshals the data that's needed, and it automates the modeling process. We literally build automatically new models every single day, select the best ones to deploy, and we take in data 24 hours a day. Some of the data comes in every 10 seconds, some of it comes in every 5 minutes, some every 1 hour, some every 1 day, all very different characteristics. All of that needs to be marshaled and monitored and alerts set. So even before you get to apply all the lovely, exciting algorithms that maybe produce useful decisions, you really have to invest dramatically in a data infrastructure.
Sacha?
Yeah, thank you. I think we might be in a different position in that, so SaaS offers a platform for utilities to do their analytics. So we get to see what they want to run. And I would say that the most popular use cases from what I've seen are definitely around asset performance, asset maintenance, and then one that's coming up related to what we've been discussing at this conference, DER, effects on the grid, is around energy forecasting and how to better integrate DERs. And I'll give an example here of a success story. And this is SCE, who actually presented this at Distributech this year. And they were suffering from what everyone else knows about the duck curve. So the difference between when their DER generation are not there is because it's not the utilities, but when DER generation is dropping while at the same time demand is peaking, and how to support that. So they needed a better net load forecasting. And from their point of view, so they have 5 million customers. At the beginning of this year, 220,000 had net energy metering, so some form of DER. And they were forecasting that was going to go to 1 million in 10 years. So 20% of their customer base was going to be generating power and putting it back in the grid. So they use the platform to see basically a real-world application of the data that they needed, all the way down to, we talked about AMI just a moment ago, so all the way down to the end of the line. And by using that, they were able to do a 10-year forecast that allowed them to see beyond just the traditional peak. They were taking into account customer demand the traditional way, but also a forecast of renewable generation. They were taking into account EV load. Pete mentioned it again, but we're not at the point of looking at vehicle to grid, so the other direction isn't taken into account, but it will at some point. So from a data point of view, the use of it, like I said, the use cases have been coming in mostly in those two directions, but they are expanding, and it does come down to being able to support your customer and the power quality, that they get, which is going to be relevant to the data quality that the utility gets.
Great, thank you. Well, we'll later on expand more on applications and customer outcomes, but I thought it'd be timely to look at the area of security, data security, the application security, given the amount of information that you've heard is being gathered. And Amir, maybe you want to share some thoughts around the whole world of data and application securities in the analytics arena?
That is such a loaded question in a time where every year the breaches get much, much more dire and the sequencing gets much heavier. The bottom line is that we have to figure things out today, as I said, at the data level or at the data sensor level. The reason is that most of our networks have been breached, and year over year you really see a lot of things which are happening, and they're getting worse. I would surmise that if you can employ into the data itself the ability to have some rules and policy embedded within, you'll have the ability to weed out things, you would have the ability to make sure things are protected, and ultimately things are possibly processed for either situational awareness or figure things out, obviously from a perspective of an infrastructure, whether things are in cycle, whether things are out of cycle, things along those lines. So to the point of Professor Tamir, AI is replete with a lot of flaws. There's a lot of, obviously, bias that comes with the processing, and at any given time, an adversarial AI can come in and kind of redirect the focus of what needs to be, what will be trained, because he's able to put some mirrors, he's able to put some listing posts, and change the whole gamut. So we got to figure things how to make sure that even what's unsupervised ultimately gets some sort of a nominal reinforcement and a mirror that we can actually come with what we would like to hopefully figure, from our perspective, what could be a good outcome as opposed to a flaw or some sort of a bias. So we have no means to really figure out how to mitigate these things, and you got to be much more oriented at the data level itself. So I like what our friend said about as far as power data, we call it smart data. And that ultimately lends itself to AI processing in much more granular, but it's much more focused on getting it also to the right audiences for them also to put their input and process to make sure the outcome is positive. So there's ways to mitigate things.
Thank you. Professor?
I guess I will skip this because I cannot say that this is my area of expertise. Like everybody, I understand the problems. Only thing that I do that relates to it is that I developed some methods that do compression and encryption at the same time, where generally people do compression first and encryption later, but other than this, I'll leave this to the experts.
Okay. David?
Well, specifically on data security, we care a lot and our customers care a lot that the data we're providing for them only gets to them and not to anybody else. And we handle that today with certain communication protocols and checks and acknowledgements, but that's not necessarily very scalable. We care an awful lot about data reliability and validity. Since we're getting it from multiple sources, its timeliness as well as its validity and lack of corruption matters a lot to us, so we focus on that. And if there's a gap in the data, because all data ultimately has some imperfections, we have to allow for that.
Thank you. Sacha?
Sacha. No problem. From a data security point of view, what comes to mind is data anonymization and aggregation to a level that isn't going to actually reveal information about consumer habits that are too directly, you're not directly able to pinpoint. So I see it as not only the encryption of it, the protection of it from a cybersecurity point of view, but as well as proper anonymization that doesn't give away what a load profile would look like for a persona, which would be easily associated to demographics.
I would say we call this zero trust proofs. That's the anonymization. So you can effectively have that metadata to work around and process while still maintaining the PI 100% private. So these are things, where things will evolve in terms of data and AI consumption. But for this crowd, which are basically the utilities, your biggest concern should be at any given time, a nation state and their proxies can come in and do anything. So you got to figure out, obviously, if you're going to renewables, you're going to holistic systems, how to begin to really figure things out in terms of protecting everything from the origination of a sensor all the way to a repository, all the way to a database that will consume and will process the AI. So you got to be very, very careful in terms of how you do so, because at any given time, as I said, adversarial AI is part and parcel. And if you take it from a macro level, what the Russians have done since 2015 is actually populate the dark web with enormous amount of tools to go after infrastructure. So this is still dire, and this is still malware that's present, and we got to figure out, obviously, how to take this out and maybe retrofit certain things. So I can go on forever, but let's, for the sake of this, let's continue on.
Great. The area of interest next up would be applications, and we had previously talked about maybe framing from each of the panelists a compelling customer outcome that we've seen that has been produced by analytics and large data sets. Maybe start off with David.
Sure. So one of our main deliverables and uses is for the owners of peaker plants, generators that typically come in units of 100, 200 megawatts and up. These are essentially they're jet engines that are bolted to the ground, and they come on when prices on the wholesale market climb to an attractive level for them. For those of you who are not familiar with wholesale energy prices, if you want to just in your browser type in ERCOT real-time price map, you will end up with a map of Texas that'll show you real-time prices every 5 minutes, and you'll see there are hundreds of dots on the map because prices vary on the market by location. So every time there's a generator or a generator unit somewhere on the grid, we help them by anticipating when prices are going to go up and when they're going to go down, or when there is a full spike, which might lead them to fire up inadvertently. The benefit to our customers of that is basically for every 100 megawatts of generation they have, we deliver them upwards of $1 million a year in bottom line additional profit. And they can get this without any capital expenditure at all.
Thank you. Sacha?
So in thinking about this and having an engineering background, I wanted to give an example that was more related to engineering, but from what I've seen, one of the best ROIs that we've seen, and with a tremendous time to value, is actually for utilities. Still data analytics application, but it's around procurement and supplier integrity. So we have a tool, it's a continuous monitoring tool. It connects to utilities ERP, it's Enterprise Resource Planning tool, the tool that basically all large companies will use for accounting, risk, compliance, et cetera, procurement. We also connect, so think SAP at your company, or we also connect to your travel booking systems, so Concur in my case, and then the HR record tool. So again, in my case, Workday. With those, we're able to see all the transaction accountings within the company. Out of the box, we have over 30 connections to external systems. And those are where the interesting part of the analytics starts, because we connect to the Department of Justice. We connect to state business registrars, and of course, to social media. So with that, we check for compliance, errors, waste, fraud, and I'll give an example of one utility. Can't name the utility for obvious reasons. Nobody wants to be named when they're checking for integrity. A large utility in the US, 10 million customers, and so asking for a success story, they gave us 45 weeks worth of their data through those internal systems I mentioned, and 6 weeks, and with that, we produced $2 million in saving. Keep in mind, this is a US utility. This is not uncommon in terms of the time to value and the dollar saving for that size of a utility. We do this for governments in countries that have more issues with corruption. So there it's even more apparent. But in there, we found 4,000 ghost employees, almost 1,400 ghost vendors, so vendors that didn't exist on any other system in a state registrar, business registrar, or any other place but within the invoicing system of that utility. Duplicate invoices, which is pretty common and can be found in your ERP directly, but the really interesting part was that they had 932 employees with the exact same bank details as their supplier. And the social media aspect came into play as well, where we found, so the system, data analytics, looks for connections on social media and the probability that you are related in some way between an employee and a supplier, usually a spousal relationship. So with that, that gave them savings of $2 million, so big success story there. At the same time, since it's continuous, it keeps that in check, so continued savings. Even more importantly, it prevented future holes from continuing on because it pointed out those holes so they could change their control and audit processes.
Thank you. A number of great examples. Pete, great ROI and customer outcomes.
Yeah, I may just highlight a little bit more in detail the town of Estes Park, which I shared earlier, the utility in Colorado. By triangulating power quality data that we capture and transport on their behalf, and coupling that with weather patterns over an extended period of time, in particular wind, and the rate at which wind is blowing, and the corresponding impact that has on vegetation that they haven't managed or are challenged to manage. It's enabled them to effectively monitor a critical circuit line in a very hard to reach area without any sensors on that line itself. So there's an amazing statistic I heard through the Department of Energy, I think a week or two ago, that 99% of power lines in the United States have no sensoring on them whatsoever. No clue as to what the tension is it right? No clue as to what the state of those lines are. And as we think about a really global phenomenon, certainly here in the United States, of wildfire risk, right? A lot of those lines are in areas that are susceptible. When the wind blows, either tension's not right and vegetation isn't maintained. Where I live in Connecticut, Eversource has dealt with that through the war on trees. They just are cutting trees everywhere. It's terrible. Frankly, not good for the environment and expensive. So with data, it's a great application. It's a great use case from our perspective. Data replaces the absence of sensors on critical power lines by capturing the right data and compiling that and correlating it to weather patterns and wind patterns. And so it changed the capital budget and the timing of when upgrades were going to be made. It tied to environmental drivers, wildfire risk drivers, and resiliency drivers for the utility. And so I like to refer to it as the data of power. It really gets and harps in on the power quality data itself in the absence of having the budget and the flexibility to deploy a lot of sensors, or in the absence of having those sensors deployed today.
Amir?
I can speak about one that we have at play in the entertainment space. We have a leading entertainment company that is trying to figure out how to create visibility between an artist to his fan base, and ultimately also provide a value in terms of those who are touching that value chain as far as royalties. So we provide that full visibility for the artist. In addition to that, we're using our ability to infuse governance into the data itself to get back some metadata from the fans themselves, just to act as sentiment mining or abilities to cross-sell to them things that would be of interest to them. So that in itself is a very end-to-end, obviously, workflow that allows us to really get into the heart of what the fan actually wants and what the consumer actually prefers. Plus, in terms of sentiment mining, there's also obviously campaigns that they can run and put some sort of proposal in terms of cross-selling stuff. The other two use cases that we have at play actually pertain to CEDAR, and we're looking into kind of solving a major problem in the water sewage that is kind of impacting the cement sector. And we're trying to figure out how to create an end-to-end from a sensor to a repository to a Fed to make sure that there is real-time analysis of what's inbound or what's out of range, so these companies do not get penalized, because the Federal Commission for Environmental Control is very, very hard on companies who are deviating from a certain range and penalizing them to a tune of $25,000 per day. The other use case that we'll go through the labs at CEDAR will pertain to digital twin implementations, where the essence is to kind of figure out there are companies today that really provide their so-called ability at the asset level to factor whether there is certain anomalies. So we can tie our technology at that point where the physical becomes digital and take that all the way into an IT environment for analytical consumption. So these are the things that we are working, and I would say that there's a lot of opportunities for this to be eventually adopted by the DOE, by the Department of Transportation. So very good stuff coming ahead in terms of our technology being showcased and tested inside CEDAR.
Great. Professor?
Okay, so I actually want to talk about an application that is in a way in the center of the theory of AI, but it is an application. So not long time ago, a former student approached me about a concern where a few hours after new game consoles reach Walmart and Target, etc., they all disappear. Web bots buy all these consoles, and then people sell them for twice the price. So the question is, how can we identify whether it is a bot or a human being? Exactly the Turing test, the imitation game. So let me back up and say that I do have some contribution. It started with research on something that is called computation with words. Because we as human beings, we don't compute with numbers all the time. If I'm following a car, I don't measure with Tesla sensors how fast it drives. I just say I have to slow a little bit, or if I have to teach a person how to park a car. So I started with this research. And then it led to a research or to a project funded by the Navy. I didn't get all the funding, somebody else got most of the funding, where the idea was, how do we identify pirate boats? And again, if you ask me, and I use my, my human intelligence, I can find a lot of things to do. So we looked into it and find things like how a boat would deceive another boat while trying to follow it. And now it takes me back to the, all of it is related to back to the web boats. So what can you do? And by the way, CAPTCHA, everybody knows CAPTCHA, and some of these are like tests that are AI tests, but today, like, identifying all these images, AI programs today can identify all these images. So the question is, what can we do? And where my contribution is that I'm kind of asking myself, what will be the difference between the activities of a bot and the activities of human being? A little bit of randomness, and again, the mainstream would be, give us data, we put it into a machine, the machine will learn and will go. In my case, I'm looking into, okay, can we measure the amount of entropy, which shows how random is the, can we see how many, can we see the patterns of interaction and use this to detect bots? So what I can say is that we have quite a good success so far. We are continuing with it. And again, just to say again, this is actually the major problem that Turing approached in 1950, which is, what is AI? I'll say more if people will ask more questions.
Elon Musk could use your services in his Twitter debate. Okay, let's open it up to the audience. We have a good 10 minutes remaining for Q&A. So please, Elizabeth, do we have a microphone? Excellent. Maybe just identify yourself, the subject matter, so our panelists can get a heads up, and then the question. It's a small group. No need to be shy.
I got a question. They're coming. I got a question. Yeah, real quick. Pete, can you help us understand a little more granularity when you talked about your solution? And I know you're trying to be, sort of polite about not selling anything, but I really want an explanation. So if I buy your new analytic platform, do I need to have your metering and networking solution?
Today, yes. In the not too distant future, no.
Okay. So you're going horizontal with this solution because the pain is really big and the opportunity is large. When you think about the opportunity itself, in terms of collecting the use cases, are you guys building a library? What does it look like? What is the sort of the process of, I like what you're showing me. How do I deploy it? What does that look like?
Yeah, so we spent an awful lot of time, Andreas, on how to structure the data that we compile. Obviously, we are much more familiar with the data we compile through our network and through our devices. That's organized in a certain set of libraries and certainly structured within the database architecture that we've got, such that we don't inundate an analytics engine with every piece of data that we capture. We can pinpoint what's the data that we are looking for relative to the problem that we're trying to solve. Our first rollout of that is what we shared with the town of Estes Park, and we've got about 35 utilities using this new analytics tool in some form or fashion. We are actively working on an analytics package on behalf of the customers at their request on transformer loading. That is the second big area of focus for us. The third area of focus is phase identification based on the data that we can pull from the devices we have in the field.
So actually, back to you again. Two questions. One of them I think is a quick one, and the other one, first of all, I feel like You mentioned that there's quite a bit of load with the electric cars, but I wonder, is that off-peak, and how does that kind of matter? Because it seems like that would be kind of an off-peak usage if it's charging overnight and things like that, and does that still create a problem? How does that still create a problem? The other piece of it is, I also feel like some of the things that you're doing seem like there could be small-scale improvements, but they kind of magnify when you do them over an entire grid or an entire distribution system, and I'd like you to speak a little bit more about how things like a water heater, when a water heater heats up, you know, something like that, seems like it's a small change, but when you do that in an entire system, it can make a huge effect. And I just wanted to hear a little bit more about that.
Yeah, I'm sure. So thanks for the question. Let me try the second question first, and then the first question second, just as who's paying attention. So the second portion of your question is, it really becomes a basis of aggregation, and I think what you articulated, it's an inherent issue within that we see. That I see when I meet with utilities. It's the notion of one small thing isn't going to have a cascading impact, and there's a lot of merit to that statement. But the extrapolation of the same thing happening in the aggregate can have an impact. I'm going to take the view of the public power and electric cooperative utility. That's who we really advocate for, and that's who we have the history of supporting. These are organizations that don't have the resources of an investor-owned utility, that don't have the benefit of getting it wrong and going back to the Public Utility Commission for rate case review, and more often than not, don't have a collection of data scientists on staff, or in some circumstances, even substation experts. So where we see concern across our existing customer base is a very specific example. What is the impact? First and foremost, where is an electric vehicle? I'm going to isolate your question to a specific application. Where is an electric vehicle showing up? For the handful of you that put your hands up that already have EVs, I think did you call your utility to let them know that you were installing a charger at the side of your house?
Actually, I have a hybrid, so maybe I was right.
All right, so that's not a fair. So you weren't. Does anyone else have an EV in the room? Did you call your utility to let them know?
No.
Exactly. Neither will I. And so utilities, right, one EV, probably no problem, but multiple EVs on the same block impacting the same pole top transformer starts to have a problem. And you could say one pole top transformer, let it blow, because that's what utilities have done historically. In today's world, that's a real problem across our user community. And our user community is from utilities as small as 1,000 meters and as large as about 250,000 meters. Right? A pole top transformer in today's world is, in many circumstances, a year to replace in supply chain. So that changes the dynamic of CapEx expenditure. And so I think what we're looking at, and as we try to aggregate data, is pinpoint where are the electric vehicles showing up, because consumers aren't letting the utility know. What is the impact that those are having at the isolated level, and then aggregating that by feeder and by circuit, if that answers your question. This first question that you asked is about variability. I think there was a data point that the Pecan Street individual provided earlier today, that it is random and no one's charging at 8 a.m. That's true on the residential side, the consumer side. Think about the electric school bus infrastructure. And we're working with another utility in Colorado, right? We're not yet coupled with their school bus charging infrastructure that they're piloting today. There are a handful going around in the country, but those vehicles are being charged at night, they're being discharged to drop the kids off, they're coming back and they're charging again, and then they're discharging in the field. And so that's a pattern that you can get some predictability on, except when there's a snow day and the school buses have to run at a different time. So I think as the world evolves, particularly with respect to EVs, you might see a pattern where it's so diversified the utility can plan, but at the same token, that's something that's really hard to extrapolate today. And so our goal is, where are they? What's the pattern? What's the data that we collect from those patterns? And then through AI, how do we predict what's going to happen as more and more show up, and the impact in particular on the distribution grid assets? I hope I answered your question. And sorry if I was too long-winded.
I'll jump onto that. Yeah, I would love to. So I have an EV, and no, I didn't call my utility either. But it does make me think, back to data that we can get from the grid and and what we can get out of that data, the insights or the decisions we can make with that. PG&E, it might be well known, ran a program where they wanted to target time of use for EV owners that were not signed up for that particular time of use. And they were able to look at their load, and an EV is hands down the largest appliance you can have in your home. So the signature of that on your load profile is tremendous. It's easily detectable. So there's going to be that complexity of mobile load that is an EV, but when it comes to detecting where it is for residential, to Pete's point, when it comes to commercial or heavy duty, it's a little bit different. There are ways to use data to define that. What we have seen, I gave the SC example, and they did take into account EV load, forecasting of EV load, and it's going to change, but right now the two major factors or the drivers were traffic and the EV charging infrastructure locations. So for residential customers, charging was still at the home, but they were seeing changes for those who had access during daytime to charging close to their work.
If I can add one more thing to your question as well, just circling back on it. It triggered something that Sacha just said. One of the things that we're also working on with utilities is something that some utilities use today, voltage conservation. Right? If you drop your voltage but stay within the parameters that utilities need to provide, it's effectively load shedding, right? Or peak savings. And so we're looking at how, as we understand the patterns of when and where EVs in particular are being charged, with data and software and computing, where those vehicles are located at the home, right? Can we effectively load limit or limit the amount of load that's going to this specific device, the EV charger, without impacting the rest of the home or the rest of the block? And so instead of taking 4 hours or 6 hours to charge a vehicle, right, based on data that we can collect and know what the thermal dynamics of that device are, right, can we trickle charge it through our gateway to EV charger with a signal that says charge but at a lower voltage, so that it doesn't take 4 to 6 hours, it takes 6 to 10 hours. That's load shifting for a utility, right? That's immediate savings, particularly for utilities focused just on the distribution side of the power equation. And so that's where the power of data, software, and edge computing all come together. Right? Collect the data, understand the analytics, predict what's going to happen, then roll out through firmware and over-the-air programming, much like we push a button on our phone and it's updated, voila, right, is reduce the amount of voltage that's going to the electric vehicle charger to protect the rest of the house when we have a big storm. It's a conservation strategy, frankly, would be very applicable here in Texas. Sorry if I'm taking up too much time.
Elizabeth, please.
So that is fascinating and it's terrifying. As a EV owner that didn't tell Austin Energy that I have an electric vehicle, and I don't have a charger at my house because I specifically don't want to charge it at the house and throw it in and have my house go into the next rate tier. Right. I exclusively charge in the field.
Whole Foods, thank you.
Well, and so as a consumer, I mean, you guys, it seems like are top down, these are great ideas. As a consumer, it's terrifying to me that someone would have the ability to turn off my charger if they decided I shouldn't be driving on a bad day. And so I guess my question is this is a lot of top down stuff. How are you gonna convince, and I do only legal things, right? There are some people that don't want you to know what they're doing in their house and what they're using their electrons for. And so So I see this as a top-down situation. How are you gonna smartify all these households that want to remain anonymous?
So you're definitely a Web3 guy. But it's, no, if I may, is that okay if I?
I also want to say something about it.
Okay, you go
So
first.
I think you are touching on a different problem, which is the privacy of information and data, and how should data flow. And without going too deep, one of my companies is called Fiberium, and the idea is that we exchange data in ways that either between B2B or between B2C, the business to customers, in ways that maintain your privacy, maintain your rights. And the main problem here, I don't want to go too technical, is the incentives. There are not too many incentives, like, you know, in Bitcoin, people get money for mining. How would you incentivize people to put data securely and then reach this data only when they are allowed? And this can be managed using many ways, and one of the ways that I'm looking into it is the distributed ledger technology, where the data is sitting and only the people with the rights, and only when they have the right to do it, can approach it. So again, maybe later more.
If I can add to it, and to your question, and Ben, you'll have to excuse me, but Ben White is in the room from Farmersville, Texas, great community here. When there is an emergency, to your question, top-down concept or utility dictating, in the circumstances of an emergency, Ben's team navigated through the deep freeze exceptionally well with the use of data and command and control in the field. The utility, right, is not, in my opinion, the goal is not to give the utility the ability to manipulate things just to manipulate. It's to adjust and modify the load profile and what needs to be delivered, particularly in time of crisis, when they have a substantial imbalance between supply and demand. And so as a consumer, I understand your concern and being terrified of Big Brother utility telling me what I can do with the asset I've purchased. The inverse to that, though, is would you rather have Big Brother call, like a lot of utilities did in California earlier this week, and said, turn things off because we're about to have a blackout. It's optionality. And in our opinion, we're going to see increases in imbalances between supply and demand. And so if the utilities are proactively in a position to better control the demand side of their equation, they can provide more reliable services, even at the expense of potentially inconveniencing you for a period of time with respect to your vehicle. But I think that's better for the community at large, slight inconvenience versus massive inconvenience and economic loss of a blackout. So that's how that's at least, and it's tension, right? Utility to consumer, always has been. So, but that's the view, that's what we're trying to empower utilities to do.
I don't think I disagree with you, but the question is how do I make sure that what you said is being done, that the data is collected for the good and the benefit and not being compromised, and that's my concern. I understand, so just to say it this way.
Just let me kind of chime in with the technology that allows you, the consumer, to have the ability to either opt in or opt out, and the data itself is a trusted party. Then you're checking, obviously, the utility and making sure that your rights are, first of all, met. And then the utility of it, you can use your common sense whether to opt in or opt out. But there is means to do so, and it comes with a digital ID. And that's how things will evolve in terms of data, AI, as well as the consumer himself. So that's something that's coming down the line, and we have means to solve these things.
Great.
Last question. David, just want to go deep into, again, don't be bashful. How do I make money? If I'm a generation guy and I got a bunch of picking units, well, how do I make money with your system, and why are you doing this?
Well, the way you make money is by making sure that you're running your generation units at the most profitable moments, because coming back certainly to the ERCOT market, where real-time prices fluctuate a lot, but they also are designed to reflect when conditions are tight and when there's a surplus of generation from wind or solar and prices can go negative. What we give them the tools to do is to anticipate the optimal time to be running and not to switch on, for example, when it looks like prices may go up, but they actually don't. So one of the things that is built into our models is, amongst other things, if you could call it a sub-forecast of net load. We talked about net load before, and there are other factors built into that, like outages, transmission constraints, and so on. So all they need from us is a signal. Sometimes they prefer the signal to go to a human being that can make the decision to throw a switch on firing up a generator or not. Sometimes they just may want it to go straight to the machinery. That's really is a matter of choice. And I'd kind of like to diverge briefly to the previous conversation about concern about individual choices. It takes us back to this whole issue of retail prices don't reflect wholesale prices. So wholesale prices are moving wildly. We pretty much insulate retail users from that. The bills they see have a single fixed price. The price signal never gets there, so they never get the option of saying, oh, tonight prices are negative, I'll definitely charge my car and I'll get paid for it. As opposed to, as it happens, there's an outage between 10 p.m. and 11 p.m. and prices on the wholesale market are really high, so that would be a good time to stop. That would benefit the grid as well as my pocketbook. And I think we need to find ways of optionally exposing more of that to customers as well.
Can I get
Okay, I want to thank our panel, Sacha, David, Professor Dan, Amir, and Pete. Please join us next door for cocktails. Andreas is toasting and treating, and we can continue the discussion.
That's right. Come and meet the superstars. Let's get a selfie. Round of applause.